Good morning to everyone. Today we are going to discuss about the subject of cloud computing. The subject code is OIT552. It's an elective paper for electronic and communication engineering and biomedical engineering. So first, coming to the part of the cloud computing, you should know about the general idea of cloud computing. So cloud computing in the sense means we are going to access the you can able to access the servers of a network remotely. We can able to store and then we can able to process the data remotely whenever we need on demand. That is, it's not like the local servers or the personal computers. So it's like a remote server which you are going to pay and then we are going to use the services from the internet. So that is a cloud computing. So here the topics which you are going to discuss is it's an introduction to cloud computing and then the roots of cloud computing. So computing in the sense means it is fully virtualized. We need to make the computers to build in a distributed way such as they can process and store the data and software services. And then the technologies such as clusters, grid, and then now it is of cloud computing. So it is a fully the virtualized manner so that the aggregating the entire resources make us to view in a single system view. And then here in case of business way, how this computing is useful in the sense means it can able to provide on demand delivery of computing power. That is the resources which they need to pay and then they need to go to access the particular resources what they need from the cloud. And then here this cloud computing can be coined as an umbrella to describe as a sophisticated on-demand computing services. So here it offers the services which is provided, that is the cloud service providers or the Amazon, Google and then Microsoft. So from these companies they are the services or cloud providers. So from them we can able to access the data and then we can able to use the resources of the cloud which is provided by them. So it denotes a model on which the computing infrastructure is viewed as a cloud from which the business and individuals access the applications from anywhere in the world on demand. So that's what I said, that they can able to access the data from anywhere in the world through the cloud. So that is the computing infrastructure is viewed with the help of a cloud. And then the main principle behind this model is that we can able to offer the computing, storage and software as a service it is provided. And then we have various definitions for the cloud computing which is defined by several scientists, namely Buya. That is he defined that cloud is a parallel and a distributed computing system. It is a collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources. That is, they provide the service level agreements. That is a negotiation between the service providers and then customers. So what they need, the customers what they need, they will be requesting to the cloud service providers. So from that based upon the service they needed, they will be claimed to pay and then to get the service. And then Vacure, the scientist who coined the definition of a cloud computing, is it is a large pool of easily usable and accessible virtualized resources. So what are all, that is we can able to access the resources virtually, which I have told you already. So that is the main concept in the cloud computing. We can able to access the hardware and then we can deploy the platforms or the services virtually. And then here regarding the services, how it can be dynamically reconfigured to the various load, or how it is optimized for how it will be the optimization will be done for the resource utilization. It's all done in the part of cloud computing. It makes resources to get aggregate, and then it is utilized well of a particular resources that can be provided to the client based on their usage or request. So this is about the definition of vacuer, which is trying to explain about the cloud computing. And then McKinsey under the core team has coined the definition for the cloud computing is: the clouds are hardware based services offering compute, network and storage capacity. So, and then the University of California Berkeley summarized some of the key characteristics of the cloud computing. That is, it's a illusion of infinite computing resources. That is an elimination of upfront commitment by cloud users, and the ability to pay for use as needed. So that's what I've said. That I've told that it means that whatever the service we are needed, the cloud service providers will provide the service for the customers based on the need. So we need to pay, and then we need to use the services. That is the internet which you need to access for about the data capacity of 2 GB I needed. So I need to pay for that 2 GB, and then I need to access that particular services which is provided by the particular vendor. And then some other the scientist as Ambrose who coined the cloud definition as data center hardware and software that provides the services. And then Sotomayor who coined the definition about the cloud is it is to refer to the IT infrastructure deployed on an infrastructure as a service provider, a data center. So most probably the same way, but the way of explaining is differ here by the various scientists. The only thing is that the infrastructure and the infrastructure of the resources, and then the software service providers as well as the platform service provider, everything will be done through virtually. So whatever we need to pay, and then we need to use it. So here the thing is that we don't need to carry our desktop or a laptop wherever we need to perform our task. So it is through remotely we can able to access it. So it is more user friendly for the customers to do the work in their place at any place in the world. So that's the main thing regarding with the cloud computing, the usage we are getting. So the cloud should have a pay per use, that is on no ongoing commitment. So that is you should use all these resources, or they are not making a commitment. So whatever you are going to use, for that you pay, and then you need to use that. Elastic capacity and illusion of infinite resources, self-service interface, and resources that are abstracted or virtualized. So these are all the cloud should have. So these are the mandatory things the cloud should have. And then we can track the roots of cloud computing by observing some of the advancements in the several technologies, especially in the hardware and then internet technologies, and then distributed computing, and then system management. So from this we can able to track the roots of the cloud computing. So here the diagram which shows about the advanced leading to the cloud computing. So it's about I told that what are all the advancements which we needed. So that is the hardware, and then the utility, and then grid computing, and then automatic computing. So everything, and then web-based computing. So everything will be coined to form as a cloud. So from mainframes to cloud. So how we are adapting from mainframes to cloud in the sense means, so here many that is the current situation which you are experiencing is we are switching from IT world, from in-house generated computing power, where the resources will be delivered over the internet as a web services. So on-demand delivery of infrastructure, applications and business processes will be serviced through the internet based upon the fee. So what the service they are needed, based upon that the commitment will be made between the consumer and then the vendor. Based upon that, the service will be allocated to the particular customer. The on-demand component of this model allows the consumers to adapt their IT usage to rapidly increasing or unpredictable computing needs. So here the providers of IT services are achieve the operational, that is the better operational cost. So whatever they are needing it, they are happy with the results of what they are requesting. And then here through the web services, so SOA and then web services, that is web 2.0 and then mashups, we are going to discuss about it. First about the web services. So the applications which will be running under on different platforms, different platforms in the sense means we will be running that for a particular application we need of different operating systems which supports different softwares we needed. So all we need we need not to be installed. We need not need to be buy the original product. Just we need to access those things through a virtual way. That is what the thing we are needed. We need to identify the providers, cloud providers, and then we need to request for the particular application and services, and then we need to use it. So after enabling the internal applications over the internet, so the consumer will be start to develop their application. So SOA, this is it is an address requirement of loosely coupled. It is a standard based and protocol independent distributed computing. So here the protocols used are WS and HTTP and XML. So these are the protocols they are using. So these are the common mechanism mainly used for delivering the services. And then for complex business logics also these services are being used. And then IaaS, that is infrastructure as services. So user authentication, payroll management, and then for calendar, everything the infrastructure as services is used. And then about the grid computing. So the grid computing is it enables the aggregation of distributed resources and it made them to transparently access to them. So here the most production of grids or TeraGrid and then EGEE which seek to share the compute and storage resources distributely across the administrative domains. So the main focus is to speeding up a broad range of scientific applications such as climate modeling and then drug design and then protein analysis. So these have been done in the grid computing. And then next about the utility computing. So in the utility computing, the users assign a utility value to the jobs where utility is a fixed or time varying valuation that captures various QoS constraints, that is their deadline, their importance, and then satisfaction. So everything have been done in the utility computing. The valuation is the amount they are willing to pay to the service provider to satisfy the demands. Hardware utilization, the main idea of the hardware utilization is we are going to utilize the resources including the processors, memory and IO devices which made them to improve their sharing and utilization of computer systems virtually. Hardware virtualization allows running of multiple operating systems and software stacks on a single physical platform. So this is about the hardware virtualization diagram where we can able to access in a single machine platform the multiple operating systems work can be accessed through a single platform. So that is through hypervisor we can do this process. So here in the hardware virtualization, the workload isolation is achieved in all program instructions, that is fully confined inside a virtual machine, which lead to improvement in security, and then better reliability is achieved through this. So if any failure of one virtual machines will not affect the other one. Moreover, the better performance control is attained at the execution of every virtual machines. So the performance of one virtual machine does not affect the other one. And then here the VMware ESXi is there, where VMware is a pioneer in the virtualization market. And then the Zen hypervisor, which is started as an open source project and has served as a base to other virtualization products, both in commercial as well as in open source. And then the layers of the cloud computing. So there are basically three classes or three layers of the cloud computing, where the service is provided to the consumers, infrastructure as a service, platform as a service, and software as a service. So these are the services provided by the provided to the customers whomever they are requesting for to use the particular service. So first is the infrastructure as a service, offering the virtualized resources, that is computation, storage, and communication on demand. Whenever they are needed, they can able to give a request to the cloud providers to access the infrastructure as a services. So this is a typical diagram which shows about the cloud computing stack: infrastructure as a service, platform as a service, and software as a service. You can able to access the app, that is a platform as service, and data, that is a platform as service. And if you are going to access a mail or any documents, so everything which comes under the cloud computing stack, that is these three layers. So and then next is the platform as service. In addition to the infrastructure oriented clouds, we are providing the raw computing and storage services, that is a high level of abstraction to make a cloud as easily programmable, that is said to be your platform as a service. Google App Engine, an example of cloud as a service, offers a scalable environment for developing and hosting the web applications. Software as a service, the applications reside on the top of the cloud stack. Here the services provided by this layer can be accessed by the end users through the web portals. And consumers are shifting from locally installed computer programs to online software services that offer the same functionality. Whereas in traditional desktop applications, such as word processing and spreadsheet cannot be accessed as a service in the web. So that is we can able to access for a software as service. How far you are accessing a drive, Google Drive, where we can able to access the spreadsheet and then a Google document. So everything can be accessed through as a software as services. So it's all about the a topic which you have discussed. So I hope that you have got the enough idea about the cloud computing introduction part, and then the roots of cloud computing which you have discussed. Thank you.